and it's my pleasure to introduce Tom. I should have asked you how to correctly pronounce your last name prior to getting started. So maybe I will let you say that. And Tom is with the Department of Agriculture, Conservation, and Forestry and the Maine Forest Service's Insect and Disease Lab. He is an entomologist and will be talking to us about browntail moth in Maine and what we probably should be aware of in Massachusetts. So Tom, please take it away.
Cool. Good morning, everybody. So as my boss always says, it rhymes with elk. So schmelk, just pretend it has one E. The Dutch Germans are a little bit crazy, I guess. Can you see that
Yes,
presentation?
Yes, we can, and thank you, Tom.
No problem. Okay, so let me just pull this up here. Okay, so thanks for that introduction. And like Tawny mentioned, I'm one of the forest entomologists for the Maine Forest Service, and I also serve as program lead for Browntail Moth, in addition to 4 other programs. But we'll get started with everybody's favorite public health nuisance, Browntail Moth. So Browntail Moth is an invasive moth originally native to Europe, and it was likely introduced on rose bushes into Somerville, Massachusetts in the late 1890s. Typically, we always refer to 1897 as the introduction date. And it's been established in Maine since 1904. So by no means a new pest, been here for well over 100 years. It is closely related to Spongy Moth, formerly known as Gypsy Moth. They are in that same family, which will come into play in a little bit here. So this is the approximate native range of browntail moth. As you can see, it covers a wide range of latitudes, all the way down into North Africa, but all the way up into Scandinavia. So I often get asked, do cold winter temperatures kill browntail moth? And the answer is a resounding no, unfortunately. So as a general rule, areas around the globe that are at the same latitude are typically experience the same climate. So coming from latitudes similar to what we are here in the Northeast, browntail is already pre-adapted to our coldest winters. So cold winter temperatures do not kill browntail. I wish that were not the case. So unlike your children, browntail moth, they are not picky eaters, and we do find them on a wide range of hosts. Most commonly in Maine, we see it in oak, birch, cherry, elm, poplar, but also basically any fruit trees. So that includes your ornamental crab apples and ornamental cherries, but also stuff like apples, pears, quince, stuff like that. So there are many fuzzy caterpillars here in the Northeast, but here are some ones that are commonly confused for browntail. You can see browntail here. The two distinguishing characteristics of browntail are these 2 hunter orange dots for the tail end here. And then you'll notice that each body segment is flanked with these white marks on either side. And the combination of those 2 characteristics are what tells browntail apart from many of our other hairy caterpillars. So I used to say that browntail moth was the only caterpillar here that had those 2 hunter orange dots. But as you can see here, this is white marked tussock moth, and it does have these 2 orange dots here. But you can see it looks quite a bit different. Looks very much like a toothbrush, I think. Okay, so now we'll delve a little bit into the history of browntail moth. So like I mentioned, browntail moth has been in Maine since 1904, and it's been in the United States since at least 1897. And when in the early 1900s, when browntail first started rearing its ugly head, there were extensive control efforts that were developed in order to help curtail browntail moth. So As I'll talk about a little bit later in the presentation, Browntail Moth overwinter, the caterpillars overwinter in these palm-sized winter webs. And this pile here next to the skid is just full of those palm-sized winter webs. So around the turn of the century, there were very extensive clipping efforts. I wouldn't even want to guess how many webs are in this particular pile here. And sort of the same scenario down here with this truck. All these burlap sacks are just loaded with those palm-sized winter webs. So some of the other things that they were doing to curtail browntail in the early 1900s, again, they're clipping and burning those webs by the tens of thousands. There were large spray projects that were initiated. So this chart here, you can see some of the things that they were spraying. Arsenate of lead, Pyrax, Bordeaux mixture, all the way at the bottom here, you got bug death. So many of these, almost all of these things are no longer used to treat browntail or pests in general, just because we know the environmental impacts as well as the human health impacts. This chemical here, arsenate of lead, is one of the reasons why in some areas of Maine, there's a higher incidence of bladder cancer. Pretty nasty stuff, and prevalent in the environment still, unfortunately. So since fruit trees and apple trees in particular serve as a preferred host, basically people that had abandoned apple orchards would cut down their apple orchards in order to prevent that reservoir of browntail from being prevalent in the environment. So this photo up here shows students at a farm school. In addition to doing the annual pruning of the apple trees, they also taught them how to prune out winter webs out of these trees. And then lastly, there was a federal quarantine that was imposed. Okay, so Babe Gunnell is a woman that grew up in coastal Maine, in Georgetown, Maine, and she wrote a memoir of her life. She was a little girl right around the turn of the century when browntail first came on the scene. And this is just an excerpt of her part of that memoir. She thought about browntail enough to include it in the memoir of her life. So I'll just give you a minute to read this. But the takeaway home point here, back in the day, those web clipping efforts were supported by a bounty that was paid to school children. So for every 100 webs that they clipped, they'd get 5 cents. And that's back when 5 cents was, you could actually do something with it. Okay, I'm gonna advance to the next slide. Okay, so this is just a little bit of the range of browntail around the turn of the century. So this is the initial introduction down here in Somerville, Massachusetts. And as you can see, this light gray area is the maximum extent. So just about 17 years to basically conquer all of New England and parts of southern Canada here, as well as down here on the tip of Long Island and New York. So 17 years, not a whole lot of time to cover that much distance, and that sort of speaks of the volume and the ability of browntail to hitchhike rides on moving vehicles, anything like that. So I was reading basically a newspaper article from New Hampshire that implicated electric cars in the 19-teens with helping to move browntail around. And yes, I did say electric cars in the teens. It's sort of a lost technology that we're just discovering now. So you can see in this darker area here, 1922. So in the late teens, early 20s, there was a big population collapse. And that sort of reduced browntail's range quite a bit. And it sort of kept falling back until it was basically found just in coastal Maine and parts of Cape Cod here. But I'll talk about that collapse in a couple of slides. So in addition to spraying and clipping, there was a huge biological control program that was instituted. So back in the day, what they used to do for biocontrol was they used to go back to the native range of the insect that was causing the problem, see what was attacking it over there, and they would just bring whatever it was attacking over there back to the U.S. Unfortunately, back in the day, they did not vet these biocontrol agents to see if they were very specific to the target or if they attacked any of our native species. And unfortunately, a lot of the flies and wasps that they brought over were generalists. And not only did they attack browntail, but they did attack some of our native species. Compsoloria contaminata, this fly here, is implicated in the decline of some of our native silk moths, particularly Cecropia moth, which I will again talk about a little bit later. So in addition to the suite of flies and wasps that was brought over for browntail, a few decades before in the 1870s, when Gypsy moth, Spongy moth, which is formerly known as Gypsy moth, arrived on the scene and was causing havoc, they basically brought another suite of flies and wasps over around the 1870s. And then fast forward to when browntail comes on the scene, a lot of these generalists also made the jump over to browntail and did give some control. This is just a list of some of the natural enemies that we find in Maine, and this is from the thesis of Carla Boyd, who is a grad student that studied in Dr. Ellie Groden's lab up at UMaine. This is just some of her findings, some of the stuff that we found here in Maine. Most of these are not extremely specific to browntail. This Tensenda delamaya is probably one of the more specific to browntail parasitoids. Okay, now time for poll question number 1.
Great, thank you, Tom, and thank you, Jeffrey, for starting that poll question. Just a friendly reminder, anyone who needs pesticide or association credits, please answer this poll question, and we invite everyone to answer it as well.
Tony, could you give me a heads up when we're good to go?
I will, Tom.
Thanks, Jeffrey.
So you have 10 seconds, to answer the question. Okay, 92% of people have answered the poll, so I'll close the poll and share the results. So the results are 1% 2015, 75% 1904, 4% 1957, 19% 1955. So you're good to go, Tom.
Thanks, Jeffrey. Okay, so now we'll sort of talk about a little bit more about the history, but this is that population collapse that happened in the late teens, early 20s. We don't know exactly why, but we have a good guess that it was due to a combination of the pathogens surrounding browntail. So there's fungus that attacks browntail, as well as a baculovirus, but also a combination of that cool, wet weather in spring. So the cool, wet weather in spring helps facilitate the growth and the spread of those two pathogens, and helps, and so the fungus and the virus are really the main drivers of population collapse with browntail. And as well as some of those parasitic flies and wasps that were introduced earlier did help give some control. Okay, so this is just a slightly different map showing the extent and decline of browntail. So like I mentioned, it sort of kept falling back until it was basically just in Cape Cod and parts of coastal Maine. And like any forest pest, moves in a cyclical fashion. So there are outbreak cycles and population collapses, and this currently in Maine, we are in the middle of the most recent outbreak that happens to be fairly severe. So the main reason that we're talking about browntail is that is a human health nuisance or a human health risk, and the caterpillars are covered in these toxic barbed hairs that give people a rash akin to poison ivy. And just like poison ivy, people react to it in varying ways. Some people react very severely, some people don't react at all, but for the majority of us, we're somewhere in the middle there. And it's most common in late June and July, because that's when the caterpillars are out and about. So this is what the hairs look like under magnification. So like I mentioned, they are hollow and filled with a toxin. So you're not only getting that chemical irritation, but they're also barbed. So you're also getting a mechanical irritation. Not a fun predicament to be in. So the life stages that have the hairs are the caterpillars, the pupal cocoons, which are impregnated with these hairs, and then also the shed skin. So as the caterpillar is feeding and growing, they will shed their skin, which has those toxic hairs on them. So the secondary problem is tree damage. So caterpillar feeding will cause branch dieback at greater than 30% defoliation, but typically, you know, in general, trees are pretty tolerant to defoliation, especially oaks, but under multiple stressors. So other species feeding on them, like winter moth or spongy moth, and with the drought that we've had for the past few years, that really puts a hurting on the trees and sort of stresses them out. So currently, we're in the 7th year of this browntail outbreak, and we are starting to see mortality due to browntail, unfortunately. Okay, so in addition to having a lot of fuzzy caterpillars in the Northeast, we also have a lot of web-building caterpillars. So this is sort of how to tell browntail winter webs from some of these other tent builders. So the first I'll start with is fall webworm, and fall webworm is one of our native caterpillars, and it will build its nest this web in fruit trees, cherry, walnut, ash, stuff like that. And people see it and they often confuse it for browntail. But there's a couple of key differences here. Probably the most stark difference between browntail and fall webworm is the sheer size of the web. So browntail moth winter webs will never be any bigger than the size of the palm of your hand. And as you can see here, this fall webworm nest is quite a bit bigger. It's about the size of a football, so very noticeable, but that size is the key difference. Okay, so now we have another one of our native tent builders, which is eastern tent caterpillar. There's a few ways to tell the difference between this. One is, again, the size. Eastern tent caterpillar webs, when they are full size, are going to be about the size of a football, so pretty large and pretty noticeable. Another difference is where the nest is. So basically, eastern tent caterpillar will build its web where the branches meet the trunk. It's a very stable environment for a large nest like that. And then it's also sort of a timing issue. So eastern tent caterpillar is building its webs in the spring, early summer, and browntail winter webs will be constructed in August, September, that sort of time period. But again, it's the size is the main difference here. So the third lookalike is probably the most difficult to tell apart from browntail. So we have two native silk moths that create a structure similar to browntail moth winter webs. One of them is Scropia moth, pictured here, which I mentioned before as having been affected by some of those biocontrol agents for browntail. But also Promethea moth will make a similar structure. So key difference here, so they are very similar in size to browntail webs, But if you think about it, it's one single individual moth or pupa that is inside this cocoon here. So it's pretty large. It's basically going to be kind of like a coin purse. And Browntail, which I'll show you in the next slide, is sort of a messier web with many leaves sort of intertwined and very silked up. One of the other ways to tell these silk moths from Browntail is that the silk on these webs sort of turns a dingier brown. It's not as bright white as Browntail will be. But just a couple of pointers. It is sort of hard to tell. So Browntail moth, finally, the culprit we've been talking about. So again, palm-sized webs, never any bigger than the size of the palm of your hand, and they're basically comprised of a bunch of leaves that are silked together. So it's sort of a messier looking web. It's not that coin purse structure that the silk moths have, but it's also this bright white silk is connecting it to the tip of the branch, and that's one of the other characteristics is the silk. And they'll almost always be towards the very tips of the branches. Brazo moth winter webs are very variable. It can be something as simple as a single leaf that's silked together. So you're only seeing the leaf, but you can see here, there's this bright white silk connecting the leaf to the tree. But most typically they sort of look like this or this. So moving into the life cycle, we'll start with what they are currently, and right now they are very small caterpillars that are overwintering together in this palm-sized winter web. And there can be between 25 and 400 caterpillars per web. So if you are able to clip any out, if they are in your neighborhood, definitely do so. This is a pretty common sight in most coastal Maine, is these very tall, mature oak trees with these browntail webs in them. One of the things you can do to survey in your own dooryard is basically to go out on a nice, bright, sunny day, stand with the sun to your back, and look up at the tops of the trees, paying particular attention to oaks, cherries, elm, birch, but also the fruit trees you might have in your front yard. So I mentioned 25 to 400 caterpillars per web, and this is a web that I brought in to the lab just to warm up. And as you can see, all these little tiny sprinkle-sized caterpillars came out of this one single web. So quite a lot in each web. So fast forward to mid-April when the weather is around 50 degrees during the day pretty reliably. And basically these caterpillars are going to emerge from their web. They're going to bask on the outside of the web to warm up, and then they're going to start looking for expanding buds or emerging leaves to feed on. As you can see here, there's this one caterpillar that has sort of mined out some of these buds and caused leaf damage that way. So after they emerge in mid-April, they're going to feed all the way until late June. And during that time, they're going to be growing larger, shedding their skin. And remember that skin has toxic hairs on them. The caterpillars have the toxic hairs that can break off pretty readily. So this is sort of the dangerous time for browntail. Okay, and then in late June, early July, they're gonna be looking for a nice place to pupate and get ready to turn into a moth. So they'll pupate pretty much anywhere that's sheltered, under the eaves of a house, on a parked car, boat trailer, RV, camper, and that's one of the ways that they move around, and hitchhike rides. So, and oftentimes they'll do it right on the host foliage. So you can see here, there's some oak leaves that are sort of messily silked together, and those are the pupal nests. There can be multiple individuals inside each one of these pupal nests. Again, take caution. These cocoons do have those toxic hairs associated with them. When the caterpillar sheds its last skin, it sort of incorporates some of those hairs into that silk. Okay, and then maybe a couple of weeks after that pupal stage, the adult moths are going to emerge, and that's typically the second week of July. And this is an adult male. And as you can see, this is why it's called Browntail Moth. It has this brown abdomen here. So when the adult moths are out flying around, they are attracted to lights, although it's mostly the males that come directly to the light. The females tend to be attracted to light as well, but they sort of hang out on the host foliage just outside of the reach of the light. So in Maine, we typically recommend that you keep your lights off between 10 p.m. and midnight in order to avoid attracting more moths to your yard. A lot of people ask me, can I use Bug Zapper? Can I use a light trap to kill these moths? And the answer is a resounding no. So unfortunately for us males, we don't matter too much biologically. So it only takes a few males to really prop up the population. Like I mentioned, most of the moths that are coming to the light are males, and we have people setting up these light traps, and they almost always call us later in the season in November, December, once the leaves are off the trees, and they have more browntail moth webs in their trees surrounding their house than they had previously. So definitely a good idea to keep the lights off, basically throughout July and part of August. Okay, so after the adult moths mate, the female is going to lay her eggs right on the host foliage, and as you can see, in August they will hatch out. So these little tiny caterpillars crawling away from this egg mass, and again 200 to 400 eggs per egg mass here. It's worth noting that the adult moths are not the life stage that has those toxic hairs. It's just the caterpillars, the pupa, and the shed skins. So basically, after these caterpillars hatch out from their eggs in August, they're going to start feeding communally. So they're basically feeding with all their brothers and sisters and grazing on the outer layer of the leaf. And this causes the leaf to die and turn sort of a bronzy copperish color, as seen in these photos that you can see from the air. And that's when we're doing aerial survey in the late summer, early fall. This is what we're looking for. So at the same time that they're communally feeding, they're also going to basically start creating this winter web that they'll spend all winter in. So this is just a summary of the life cycle, and the takeaway home message here is that the highest risk exposure for hares is between mid-April and mid-July, and it could be year-round if you have a heavily infested area. A lot of hares in the environment, and that toxin is very stable in the environment. Okay, now we are ready for poll question number 2.
So the poll question is up. Poll question will close in 10 seconds. Poll post. Share the results here. So the results are 97% saying false, 3% saying true.
Cool. Thank you, Jeffrey. Okay.
Let's see here. Tony, do you see whether because I'm seeing the poll question slide.
I do as well. Let's see.
And so try to do this, I take the screen from Tom and get it back to him
Okay, hang
in
on
a
a
way.
second. Apologies, folks, here. I will show my screen and try to pass it back to Tom so we can get the poll question view to hopefully disappear. Here it goes again, Tom.
Okay.
There we
Again.
go.
Good to go?
Yeah.
Yep.
Yeah.
Cool. Okay, so now we'll move into the current situation in Maine. So like I mentioned, Maine is in the 7th year of the most recent population outbreak. It started in 2015. That's when we first started seeing elevated numbers. And this year it has further increased its range in Maine. The most heavily impacted counties include Androscoggin, Kennebec, Knox, and Waldo, which happen to be some of the most populated counties in Maine. So call activity was very, very high this year. The Maine Forest Service received well over 500 Browntail Moth calls, as well as just as many emails. And that's basically from a time span from May to mid-August. And then that's also not including a lot of the other calls fielded by some of the other agencies like 211, Bureau of Ag, and CDC. So a lot of people affected, a lot of people calling. So this year, so we fly 2 rounds of aerial survey each year, 1 round in the late spring, early summer to pick up actual defoliation, and then another round in the late summer, early fall in order to pick up that skeletonization damage from the young caterpillars. So this year, with both rounds of those aerial surveys, we mapped almost 200,000 acres of defoliation, and that's up about 47,000 acres from last year. To put this into perspective, so the last outbreak that we had in the early 2000s, it was maybe a maximum of 10,000 acres defoliated. So this is quite an order of magnitude larger than that. And this is some of the views that we see when we're doing the aerial survey. It's a little hard to see, but these areas here that are sort of a brownish grayish color, those are stands of oak trees that have been completely defoliated by browntail. And this is during that late spring, early summer survey. This is a bog bank out here over the ocean. This is right around Camden, Maine. So the pathogens that surround browntail, so I mentioned the fungus and the virus, those are really the main population crashers, you could call them. So we have monitoring sites throughout the state of Maine to report on weekly developmental updates, but also to keep an eye out for these fungal and viral outbreaks. Wasn't expecting to see any any pathogen activity this year, since it was a drought for the 3rd year in a row. But fortunately, we did see some pathogen activity, although it was very isolated. Just a single apple tree that had 100% mortality, and then down the road, browntail was doing just fine. One of the good things about this, though, is that it's very widespread in Maine. So all the way up in Blue Hill, down through Belfast, Liberty, and Jefferson are where we picked up some of these pathogens. So that if we do have cool, wet weather, particularly in May and June, so a normal spring, we're likely to see a region-wide population collapse, although it might take 2 years since the population is quite enormous right now. So this is down in my house in Dresden, and as you can see, so there's this caterpillar here that's infected by by the baculovirus that attacks browntail. And as you can see here, it sort of happened very late in the season. So these caterpillars are getting ready to pupate and turn into moths. So it didn't quite have a huge impact this year, but it is very nice to see that it was widespread. Some other pathogen activity that sort of took us by surprise. So in September, when I was checking out some of the winter webs here on the state campus, I found a lot of these webs had caterpillars that were basically melted into the leaf surface here. And I don't know exactly what pathogen caused this, but it looks a little bacterial to me. but good news, and I'm hearing more word that this was pretty widespread. In addition to that, we did, as I was checking these webs, did find some parasitic flies, sort of probing the nests and checking them out. This is one of those tachinid flies here. So in addition to those findings this past year, we did find, it only shows 2 here, but we did find 3 other locations, satellite populations that we found a single winter web at. This was happening last winter. So this area circled here in red is the main bulk of the population in Maine. And as you can see, these are pretty far removed. And this sort of represents one of the first times in, you know, a very, very long time that we've seen it up in the county, up in Aroostook County here. So another testament to how well it can hitchhike. So moving into management. So I always stress that the first step to management is education. We are trying to raise awareness, and we do this every year, but this year, Browntail Moth Awareness Month is in February, official, signed by the governor. And the reason why we're doing this in February and having these informational sessions is just to make people aware that's what's happening in their own dooryard. Many ways to get the community involved: web clipping events, townwide surveys, web burning, web clipping contests, stuff like that. And the reason why we chose February is because the winter is probably the best time to get out there and manage browntail. A lot of the webs, especially in the fruit trees in people's front yards, are low and clippable and very visible. And there's many other benefits to clipping webs in the winter, and even just being informed where browntail is in your yard can sort of help inform your management decisions. So these photos here are from a web clipping event up in Deer Isle. Deer Isle is one of the best examples of community-wide effort to control browntail. It's always a good time. So in addition to doing those 2 rounds of aerial survey, we also do a winter web survey where our technicians drive the major roads within the state of Maine and basically plot out and drop points where basically they're estimating the number of webs per tree. So the hotter the color, as you can see by red and orange, the more webs per tree there are. And this is sort of overlaid with our aerial survey data here. So you can see we cover quite a bit of ground, and this year we will be covering even more. And this survey is currently ongoing. This is just last year's data. So just a point, another thing to drive home that it's a good hitchhiker. So this is one of the satellite populations far away from the main bulk. And as you can see here, there's a few webs shining up in the top of this tree here. And the answer to how these got here is right in this picture. So what likely happened was that these folks went down to the coast, accidentally, unknowingly brought browntail back with them, and sort of started a satellite infestation. So definitely check those vehicles and make sure you're not moving browntail. All right. Johnny, can you hear me?
I can now. You were cutting out a little bit briefly there at the end, and we seem to be seeing your desktop now.
Yep, sorry. The power just went out in the building really quick.
Oh no, we are having issues with power outages, it seems, this morning. Okay. Well,
yeah, hold on.
Take a second and get back together.
Sorry.
No worries, we can hear you. We still see your desktop. I can tell you once I see your PowerPoint come up.
Okay, let me just. Okay, let me just backtrack here a little bit. Can you see the presentation now?
Yes, yeah, and we're on your control don't move BTM.
Okay, perfect. Sorry about that. Okay, so more points when you're traveling in these infested areas. Don't park under these ornamental trees that are in a lot of shopping centers or doctors' offices, and you're going to want to make sure that you check that you're not moving caterpillars, cocoons, or adult moths. Okay, so obviously you're going to want to avoid heavily infested areas in the summertime. One thing that a lot of people forget is that if you do live in a heavily infested area, you're going to want to dry your laundry inside. You know, the hairs become airborne and can blow into your bed sheets, and that's one of the last things that you want, is to have Browntail moth in your bed sheets there. Also, one of the most common ways that people come into contact with these hairs is by doing outdoor activities like gardening, opening up camp, brush removal, stuff like that. So just try to take as many precautions as you can. And some of those precautions are just wearing PPE, so coveralls, Tyvek suits, masks, goggles, and gloves, and all help. And one of the things that our technicians use is these pre-contact poison ivy wipes, and they will help close the pores in your skin to help prevent those hairs from sticking in. One of the other things you can do is, if you are in a heavily infested area, just wet the area that you're working with down with a hose, or try to mow on, in the morning when there's dew, or a day after it rains. I know it really sucks mowing grass when it's wet out, but it's preferable to having browntail moth rash. Also, one of the things you can do, a lot of people call me, the caterpillars are crawling on their house, and what can they do? And one of the things you can do, if you have a wet, dry shop vac with a good HEPA filter on it, you can put a couple of inches of soapy water in the bottom of that, and that will do two things. It will kill the caterpillars, but it will also prevent the hairs from, getting blown right outside the vacuum. So it's a good no-touch approach. Okay, as I mentioned before, cold winter temperatures do not kill browntail, but cool, wet springs do. And when we have wet weather in May and June, that helps the fungus and the virus really spread, proliferate. Some of the natural enemies that we talked about, like the flies and wasps, aren't necessarily effective at very high population levels. Okay, and now we are ready for poll question number 3.
Thank you, Tom. And another reminder to folks to please answer the poll question. Everyone's invited to participate, but particularly those looking for pesticide and association credits. Tom, while we're waiting on polls, it's a good moment to remind you we have about 10 minutes left, as I want to leave ample time for questions. We've got a lot of good ones for you.
Yep, sounds good. I think I just have three more slides that I'll sort of go through pretty quickly.
Perfect.
So I've closed the poll. I'm not going to share on the screen, but I'm going to share the results verbally because I don't want us to get stuck there. So the results are 88% said fungal and viral pathogens, 10% clipping webs, and 2% stitchwear and spraying.
Thank you, Jeffrey. And Tom, we had a request. Can you just clarify which answer is the correct answer?
Yeah, so the main driver of population collapses is that the fungus and the virus.
Thank you. All right, you're good to go.
Okay. So just some tips on eliminating browntail webs if you do have them in your yard. Pruning them out if you can reach them with pole pruners or a ladder. And you're going to want to destroy these webs when you clip them out. And this is best done all before mid-April. That's when the caterpillars sort of reemerge and become active again. So chemical control, if you do decide that you want to do the chemical route, you're going to want to do this before the end of May. So you're basically trying to get them when they're small enough, but also when the trees have enough leaf surface to spray on. If you do control later, most of these management strategies are focused on mitigating people coming into contact with the hairs. And if you do that after the end of May, you will still be killing caterpillars, but there will be a lot of those dead caterpillars and the associated hairs with them, in the yard. And obviously, you'll want to try to hire a licensed pesticide applicator if you do go the chemical route. So then the last slide here is tree injections. A lot of people calling us about do-it-yourself tree injections or just asking about tree injections. So we did revise our frequently asked question page and did add a bunch of these questions. But the most commonly active ingredient for injections is acephate, and you're trying to inject these trees basically when they're moving water and nutrients, which is around bud burst. And you're going to want to focus on trees in high traffic areas that are overhanging your deck of the house. Don't really worry about trees that are sort of further away. So some of these systems or products can be used by homeowners, but you're going to want to follow the instructions word for word. There can be a lot of user error. And with that, I will take any questions.
All right, thank you so much, Tom. We appreciate your excellent presentation, a lot of great information, and there's a lot of good questions here, so I'll just get started. First one from Kristen is a great place to start. You mentioned browntail moths were introduced in Somerville, Massachusetts. Do you happen to know if it was a private residence or was there a nursery or plant sale business? Do we know the history of how it accidentally was introduced into Massachusetts?
Yeah, so the story that I always hear is that it came over on rose bushes into a florist shop, and that florist shop happened to be right near a railroad depot, and that's one of the ways that it spread. The caterpillar sort of hitched rides and spread that way. But yeah, florist shop, unfortunately, is what I always hear.
Thank you. All right, let's see. Next question from Sue. Does the same fungus that kills the spongy moth caterpillars also kill browntail moth caterpillars?
So it's actually so the fungus that kills browntail moth is actually in the same genus as the one that kills spongy moth. So the one for spongy moth is called Entomophaga maimaega, and then the one for browntail is called Entomophaga aleki. I'm not sure if there's any crossover. I think they're fairly specific, but it's possible that there could be some crossover, but two different species.
Thank you. Let's see. So a couple of related questions here for clarification. One question from Celine. What are the common scenarios that bring people into contact with browntail moth caterpillars? You had shown a picture of a woman that had an allergic reaction on her neck. How does that happen? And I want to, if I can, add to that, can you just clarify the current geographic region in New England and New York where the public might actually be able to come into contact with browntail moth? We assume it's coastal Maine and potentially parts of coastal Massachusetts are currently at greater risk, right, of coming into contact with these insects. They're not geographically very widespread. Is that correct?
Yep. So basically, it's just in Maine. So it used to be confined to coastal Maine, but it's also sort of moved inland and northward. But yeah, so Maine and Massachusetts are the only two states that have resident populations of browntail. So going back to that question, how do some of those rash scenarios happen? I'm not quite sure how she got it all the way on the back of her neck. But typically it's when people are opening up camp, cottage, doing yard works, leaf blowing, especially if it's hot and dry, those hairs can become airborne pretty readily. And especially if it's in a sheltered place, so there's leaves that collect under a deck, those areas don't get a whole lot of precipitation and the hairs sort of stay dry, and people come into contact with it like that. But it's most often doing yard work or working outside in the yard.
Thank you. Appreciate the clarification for everyone. Let's see, another question here from Sandra. Do the female and male moths look similar? How can you tell them apart?
Yeah, so they do look very similar. The photo that I showed of the adult moth, that's a male. So males have sort of fern-like or feather-like antenna. And females have more thread-like or filiform antenna. Also, the females will have a larger abdomen, just because she's carrying the eggs. But look for the antenna is the main way to tell them apart.
Another thing to point out, not just lookalikes with the caterpillars, but there are other white moths, correct, that are native to New England? Not every white moth is a browntail moth.
Oh, definitely. And that's probably one thing that I will add to this presentation as time goes on. But satin moth looks a lot like browntail. And then there's also some of the tiger moths that are very white that look like browntail. But yeah, sort of during that July time period, but also just looking for that brown abdomen. There's no other pure white moth that has a brown abdomen like that.
Thank you. Let's see here, another question from Sue. Can you perhaps just clarify the host plant list of browntail moth? Again, Sue was asking specifically, could they eat vines like poison ivy?
They can't eat vines like poison ivy, but it's basically oaks, black cherry, elm, poplar, birch, but any fruit trees really, and also anything in the rose family. So they can eat multiflora rose, but also your like apples are in the rose family, but you know, your garden roses as well. I know down in Cape Cod, you typically find it on beach plum, which is also in that rose family. But yeah, they're not picky eaters. Technically, maple is on the host list too, but we only really see it in maples when there's spillover from a high population in oaks. So very wide host range, but yeah, you're probably not going to see it on poison ivy, unfortunately.
Great, thank you. Let's see, another question here from Phil. Aside from pruning, what are the controls? You did mention those at the end of your presentation, and Phil is coming from Long Island.
Oh, okay. Fellow New Yorker. I feel that. So basically the other control methods, so other than clipping, which is the most preferred, especially if you can reach them. I know it's not feasible in very tall oak trees, but clipping would be number one. But there's those tree injections that I mentioned, but also hydraulic or chemical spraying. And I know there's a lot of companies that have mist blowers. That's usually pretty effective and a good way to not put a lot of pesticide out into the environment.
Thank you. Let's see here. Another question here from Edward. Can satellite data provide information for us about browntail moth defoliation versus airplane gathered data?
Not possibly. I would say that the aerial data from the airplane is probably the most effective. We can sort of ground truth that data as you can with satellite data, but yeah, it would sort of be a timing thing with the satellite data in order to get it at the right times that you want to pick up the skeletonization before the leaf change in the fall, but then also sort of narrow down the area that you're looking at with the satellite data.
Thank you. I know that it's been done for Spongy moth in the past, or actually in the most recent 2017 ish outbreak, but yeah, I haven't seen it for browntail. From Anissa, I hope I'm not mispronouncing that. Can browntail moth webs survive on the ground if clipped and not collected?
No, so that's one of the bullets that I had on the slide that I didn't mention is that when you clip them out, you want to make sure that you destroy them, and you can do that by soaking them in a bucket of soapy water overnight or burning them. Typically, when those webs will survive, the web is hydrophobic, so it repels water, and those caterpillars have a very good survival instinct and will climb right back up on the tree.
Thank you. Another question to add, can individuals have an allergic reaction to the overwintering caterpillars, even though they are tiny? So assuming that larger caterpillars might present greater risk, but for anyone, say in Maine, clipping browntail moth winter webs, is there certain personal protective equipment you recommend?
Yeah, so I would say that if you are a sensitive individual, you might just want to take all the precautions that you can if you're clipping the winter webs. So even the small caterpillars do have some of those toxic hairs on them, but as you mentioned, when they grow bigger, they have more of them. One of the reasons why we recommend web clipping is because the hair activity during that time is very, very low. So you have a very low chance of getting a rash. But just wear gloves, wear long sleeves, just regular proper PPE would be great, especially if you know that you're sensitive.
Thank you, Tom. Excellent. And thanks for all these great answers. And there are tons more questions, and we have time before the break, so I'll just keep going. And a lot of folks saying thank you, great presentation. Stephen is curious to know, when will 2022 data be out to look at he's asking specifically for Maine.
So typically we try to wrap up the winter web survey in like late March and try to have that data available on the website by April at least. This year we are a little bit ahead of schedule, thankfully, or mercifully, I should say. So hopefully we'll have that map or data closer to the end of March. It's just a lot of driving, a lot of road to cover, and then also just trying to collate all that data. But I guess this would be a good moment to plug. So if you go on the Maine Forest Service website on the Browntail Moth page, under survey and management resources, that's where you'll find that winter web data from past years as well. There's an interactive dashboard, so you can sort of zoom in and see what's going on in a particular town.
Thank you. I'll try to, when I get a second, share that website in the chat with everyone. Question from Robert: will an insecticidal soap application work on managing these in early spring?
Yeah, insecticidal soap will work, especially if they're all together basking on the outside of the web. But unfortunately, it will. It's not going to put a huge dent in the population going with a spray bottle web to web. And I would recommend that if you are close enough or you can reach it with a spray bottle, just to clip it out before mid-April. That would probably be best.
Thank you. Let's see, next question here from Roland. When using chemical management, you say to use Acephate. How many applications would you recommend throughout the year? And so I guess this is specific to a systemic injection of trees.
Yeah, so just I've never done these applications by myself, and we are lacking field trial data. We just don't have the staff or the resources to be able to do that. So the efficacy data is not all together, and what we rely on are mostly arborists and professionals in the industry sort of relaying what works. And so when you do the tree injections, it's typically once a year, and you're going to want to, again, try to make those injections when the tree is moving water and nutrients, so around bud burst, but it's typically once a year. I know different products have different residuals on the tree, and I think there are some that claim you can get a couple of seasons with one injection, but it's typically one one injection.
Fantastic answer, Tom, and I'll add to that to always follow the label instructions on any products that you are using. Carol has a question. Are browntail moth caterpillars or moths on Cape Cod? And she's asking, what is the active ingredient in acephate? Carol, the active ingredient is acephate itself. So products containing the active ingredient acephate.
Yeah, and it is on Cape Cod. So Maine and basically Cape Cod are the only places in the U.S. that have resident populations of browntail. And I've never been to Cape Cod to check on the browntail, but from what I hear, it's usually on like beach plum or scrub oak and doesn't really explode like it does here in Maine.
Thank you. And we might hear a little bit more about that from our next presenter, Nicole, but we still have some more time before the break, so I'll keep going here if you're willing, Tom. Another question here from Anthony. Have there ever been attempts to control populations with large aerial spraying of BT or Bacillus thuringiensis?
Yeah, so I think that a lot of the aerial applications happened before my time. I think the last aerial application that we had was in the early 90s, and I was still toddling around in the early 90s. But yeah, we haven't had a spray program, a statewide spray program in a long time, and that's for a few reasons. One, because the control is more effective at the town level. But also, we're not going to spray our way out of this situation. I don't really know what chemicals that they were spraying back on those earlier applications, but I don't think that it was BT. I think it was something a little more general. But yeah, so that, and then also staffing and budget, things that every state is dealing with.
Thank you. Cheryl has a great question. Since they spread so readily, what limits the spread further throughout the region?
Yeah, so that's kind of a $1 million question is, if browntail is always prevalent in Maine to varying extents, why is it not all throughout New England again? And I think there's been a few studies in the past. One of them, I think, found that it sort of has to do with like the parasitic flies and the wasps. The populations throughout New England of those other species are help give some control for browntail, but I don't think that's the whole story. And like I said, it's $1 million question, and I always sort of wonder that, why people have to be taking some of these caterpillars or pupa back with them when they visit Maine. Why are they not establishing other populations? But I think a lot of it does have to do with those parasitoids.
And accidentally taking them all, I'll add, right? Question here from Thomas and some comments. I think his question is there grant money for arborists to work in Maine, I believe, on browntail moth management, or does the state cover the cost? And he unfortunately mentions having interacted with the hairs from these caterpillars and suffering a rash.
Yeah, so unfortunately there is no state funding at this time. There is currently a bill working its way through legislature that, among other things, has a small fund of money in order to help supplement some town-wide control programs. But unfortunately, it's not a whole lot of money compared to the towns that are affected. But there is no state funding for control like that.
Question from Curtis: can the hairs cause respiratory problems in people?
Yeah, so technically they can definitely cause respiratory issues. So I've been with the Maine Forest Service for 3.5 years now, and I've fielded hundreds and hundreds of calls, but none basically I've never heard of anybody contacting me about the respiratory issues. It's like 99% the rash.
Thank you. Let's see the next question here from Roland. Also, would you recommend applying a horticultural oil application early in the year before they become active to suffocate the egg masses? So maybe clarify the life cycle too.
Yeah, so in the spring, it's the caterpillars that are coming out of the overwintering web. So the egg mass, that happens when they hatch out of the egg mass. That happens in August. So I could see horticultural oil being useful for the actual egg mass in, back in August. But I have a feeling it might be a little bit less successful for the emergent caterpillars in the spring, just due to the nature of the web. It's very convoluted, very messy. It's got a lot of ins and outs, and basically it would be hard to soak that web with enough horticultural oil, even just on the surface, for it to really make a huge difference.
Thank you. A question here from Cray. Do the caterpillars use silk and move via the wind like spongy moth caterpillar larvae?
I'm actually not sure if they do balloon like spongy moth. From what I've seen, they tend to just drop straight out of the tree. If they're running out of food, leaves in that tree, they will just drop right out. And I've had some drop right on me doing some of these field site visits. So I don't think that they balloon, but I could totally be wrong about that. I've never seen it.
Thank you. A question from Scott related to this. How far can the browntail moth move on its own distance-wise?
Good question. So the adults are fairly good flyers. So unlike spongy moth, the females are more apt to fly. So and they do sort of carry on the wind at times. So our colleagues up in Nova Scotia have alerted us to finding browntail moth at some of the lights in Nova Scotia, and that's sort of, I don't have like a mileage per year number to give you, but basically they can fly pretty well, and the reason why it's more moving north than it is south is because of the prevailing winds are more of a south to north wind. So that's one of the causes of the northward expansion.
Thank you, Tom. I'll try to combine maybe a couple more here very quickly, and then I want to make sure we give time for everyone to take a short break before we introduce our next speaker. A few questions about rashes, treatment, and clothing here. So I guess I can just start. What is the typical treatment for people with the rashes, and how long does a rash, or might a rash, last on the body, and is it capable of spreading?
So a few questions there. So it's not like poison ivy. So it's not in the poison ivy in the sense that it doesn't spread. So it's single hairs that are sticking in the skin. So it's not an oil like poison ivy. So it won't spread like that. So I'm also not a medical professional. I don't have a medical license, so I technically can't give medical advice. But some of the things that I've heard people saying that helps: Benadryl, calamine lotion, salves with witch hazel in them. And there are a bunch of coastal pharmacies here in Maine that do whip up a browntail moth lotion to help with the rash. One thing I might recommend is a nice boxed wine to maybe dull some of the pain. I know I've used that method in the past when it's been really bad. But yeah, so there was a third part of that question.
I think you covered it, and yes, thank you for saying we are not medical professionals and can't give medical advice, and we suggest if anyone's suffering with this to go or contact your primary care physician. I think maybe sort of related last two to those are sort of what does the rash feel like? I've heard it's been compared to having poison ivy in some folks, but as you've alluded to in the past, it depends on an individual's sensitivity. Is that correct?
Yep, exactly. So like I mentioned, some people don't react at all, some people react severely, but most of us are sort of in the middle. And from having it does feel a lot like poison ivy, which is unfortunate.
One last one. After removing browntail nests, clothing is likely to be contaminated by the hairs, or anytime you're interacting with those life stages you mentioned. How can you safely clean contaminated clothing?
Yeah, so one of the things I might mention, so in coming inside from doing yard work or areas that you might have been exposed, is to take off the clothing and put it in the dryer. Don't wash it first, just put it in the dryer. Sort of cycle it on high heat. There is evidence that the toxin is broken down by high heat. At what temperature it breaks down, I couldn't tell you, but we have had sort of success in the past, at least with some of my own field clothing. But actually, I should mention before you even do that, get a lint roller or some packing tape and sort of roll down the sleeves, and that will help pick up some of those hairs that might be resting on the sleeves of your shirt, or even a good thing to do just to any skin that might have been exposed.
All right, thank you so much, Tom. Well, I want to give us a few minutes of break here before we introduce our next speaker, Nicole. So we'll get started. So I just want to, and it's my pleasure to introduce Nicole Kelleher, the Forest Health Director for Massachusetts Department of Conservation and Recreation, and she'll be giving us an overview of invasive forest insect pests in Massachusetts, those from our past, present, and future. That's the one that really gets me. Hopefully not, right? But ones that we should be looking out for. So thanks so much, Nicole, for being here, and take it away.
Thanks, Tony. So my name is Nicole, and I lead the DCR's Forest Health Program, and a huge amount of what we do is insects work, particularly invasive insects. I know there were some questions about browntail moth, and I didn't really talk about it in this presentation because Tom did a great job, and I knew he would go over it really thoroughly. But we do have pockets of it here in Massachusetts, and we really do mostly see it only out in coastal areas, mostly on our little shrubby trees, so out on those beach plums and those scrub oaks. We did see an uptick in reports of adult moths flying last summer, but we've been working on some web surveys, and we're not seeing huge densities or really concerning populations down here, luckily. And my biggest guidance for people that are looking to avoid the itchiness is when you're out at the beach, when you're out in these coastal areas like hiking and working, stay on the trail, don't go cutting through the trees, because most of them are mostly hiding in those little patches of scrubby trees. But I do think Tom's browntail presentation was a great introduction to this, kind of talking about pests that have been in our past, our history of invasive insect management, what we're kind of doing now, and what we're kind of expecting for the future. And how we approach invasive insects has really changed drastically. So in Massachusetts, in 1880, we had our first program established for addressing invasive insects to deal with gypsy moth. And kind of over the years since then, our approaches have really changed, our concerns have really changed, and the pests that we're going after have really changed. And in my mind, I kind of think of it for insects in these like three phases. So the first is the moths. So it was called gypsy moth then. We know that there's a name change, so I've been calling it LDD. The new name to spongy moth isn't fully official yet, but is coming, will be rolled out soon. So LDD came into Massachusetts in 1869, pretty quickly became a very significant issue for our forest, causing huge defoliation events. And the state realized we needed to do something about this. Then browntail moth kind of came in, and dealing with those two insects for a long time was a big focus. And then we kind of moved into a period of time where diseases were a bigger problem. So we had our chestnut blight, Dutch elm disease, beech bark disease, white pine blister rust were a really big focus for forest health management. And then later in the 20th century, the piercing sucking insects kind of became a focus. And then kind of more recently, as we moved into the 21st century, it's the time of the beetles, and really these invasive beetles are some of our bigger concerns. And these changes kind of happen because of how our global trade and how things are moving and how different insects can get here and establish, and how we're using our forest resources have really influenced why we're seeing new insects, how we're seeing them, and how they're really impacting our forests. So in the forest health program, we use a few different steps to kind of deal with invasive insects. The biggest is early detection. So if we can find a pest early on, we have much better chances of limiting its impact, limiting the decline in our trees, and possibly eradicating it. If we're not finding it until it's well established in multiple areas and stands and different kinds of trees, it's much harder for us to deal with that point. We also do a lot of detection mapping. So when we know an insect is already here, identifying where that population is, how it's expanding, how it's growing, what densities are like, and collecting a lot of data on that, and producing maps so we can really share the information with people. And I'll be sharing a bunch today. We do long-term monitoring to see how our forest resources are being impacted by these insects. So year after year, what it's actually causing in our trees, how we're seeing it manifest in the overall health of our forests. We do some treatments, so we do some pesticide treatments in trees. We don't really do too much silvicultural treatments specifically for pests, but there are sometimes a need for that. And we also release biocontrol species that are targeted towards some of these invasive insects. And we utilize a lot of different survey methods and tools, but the biggest method, or one of our biggest surveys each year, is our aerial survey. So myself and one of the other foresters get into a tiny little airplane with a pilot. We're all squeezed in there, and we fly over the entire state in grid lines and map all of the damage that we see from the air. We then spend a bit of the summer going out to all of those places on the ground and really seeing what was the damage, how severe it was, and trying to figure out what actually caused it. Sometimes it's really easy. It's very obvious what the issue is, like Gypsy Moth defoliation. The defoliation is very clear and obvious. The hosts are clear and obvious, and you'll see egg masses around even if you miss the caterpillar. Other things can be a little bit more cryptic and take us a little bit more of a deep dive into to figure out what was actually going on. And this is a tool we've been using for a very long time, and it helps us kind of capture this like big picture, broad snapshot of what's happening here in the state. So we usually time it to line up with the things that we think are going to be the bigger concerns for the year, or the events that are more damaging to our forests. So in most recent years, it's been late June to try to capture defoliation from our defoliating caterpillar species like Gypsy Moth, and also capturing white pine needle discoloring that really peaks in late June. So we try to fly to capture the most of that, and sometimes there are additional needs to fly later in the season or in the fall to see something else that had happened. Sometimes when we have bigger tornado events or other abiotic events that cause damage, we'll fly specifically smaller areas just to be able to accurately map and assess that damage. But we've been utilizing aerial survey on and off from the 30s to the late 60s, but since the early 70s, it's something we've done every year, and we have this really great data set to show kind of the big changes, and we can kind of see that there's insects that really rise in the acreage and the numbers, and they'll peak and then fall, and we haven't seen them again for decades. Or there's some that are really cyclical, and they'll come in and out, and we'll see them in certain areas. And some of these insects and diseases we'll see widespread across the state. Others are really, like Browntail Moth, very limited to certain areas. And it's really interesting to look across time and see how invasive insects have really changed what we're seeing in our landscape. So this map kind of goes through, and it is a little rough to see, but it is kind of cool just to watch the amount of areas and impact from year after year. And some of these are abiotic factors. There's quite a lot of our native insects too that go through these periodic outbreak events, but there is a big drive by our invasives, and the bright red is gypsy moth, and that is kind of this ongoing pest that year to year really is something that is always out there in our forests. So Spongy moth, Lymantria dispar, formerly known as gypsy moth. It is a defoliating caterpillar species, so it hatches late April, early May, and gets out in those trees and starts feeding. It has a pretty wide host range, will feed on over 300 different species, but it really loves our oaks, which makes Massachusetts, it was a great landing point for it to establish here in the US because we have a lot of oak forests that were easily available. So it quickly became a problem. We went through these periods of outbreak, and our approach to control really had changed over time to it. So you'll kind of see, I will say a caveat when looking at acreage numbers is our methods for survey detection and calculation, and they didn't always have super nice computers where it was easy and tablets to easily map everything. So take the exact numbers with a grain of salt, but the pattern it really shows that there are these huge peaks, these years of outbreak events, then years of it kind of lying low. But it was kind of in the last 150 years, it's been a consistent in our forests. And when it first started the program in 1880 through 1900, when they were working on eradicating and minimizing its impact, it was very labor-intensive work. They didn't have as many of the technologies and tools that occurred later. It was a lot of egg scraping using very coarse materials, arsenic and creosote, and kind of things that we would never think to put on a tree nowadays, banding trees and covering them with tar to get caterpillars stuck in it and covering the egg masses. And it was somewhat effective, but they never got all of the caterpillars. So they put in all this effort and really time intensive, and then would be like, wait, we did it, great job, take a year or two off, and then all of a sudden gypsy moth would be back again. And eventually we had trucks and airplanes and chemicals to spray, starting with things like DDT and eventually moving to more biologicals like BTK and Gypcheck. But in the 70s into 80s, we had huge outbreak events where these control methods weren't really doing much, and the populations still built up, still got huger and huger, kind of peaking at the highest amount in over 2 million acres impacted in 1981. And then all of a sudden, late 80s, population crashed, weren't seeing it anywhere, and researchers got out there and realized Entomophaga mimega, which is a host-specific fungal pathogen, became established and was decimating the caterpillar population. So it is a fungus that kind of has resting spores that wait in the ground in the off season, and then in the spring when the caterpillars are active and it's nice and wet, those spores become active, get on the caterpillars, penetrate into them, and will kill the caterpillars in that springtime period. So it's focusing on the caterpillar life stage. So they'll usually start eating and then die off when they start to get a little bit more mature. But it was something that they had tried to establish back in the early 20th century when they were releasing all those other biocontrols, didn't really have success. And then all of a sudden it was just becoming really widespread across the landscape in the late 80s. And no one really knows exactly how that mechanism had worked. But the population declined. We went through 3 decades of very low level gypsy moth populations, pockets here and there, but not those huge widespread events, until 2015, where we started to see a buildup. We had dry springs in 2015 and 2016, which limited the effectiveness of the Entomophagum omega fungus and allowed gypsy moth populations to build up. And we had huge amounts of defoliation in central and eastern Massachusetts. And it led to quite a significant amount of oak mortality. We had 4 years of significant gypsy moth defoliation, and in that time we also had a very severe drought in 2016, which further stressed our trees out. So you can kind of see we saw our defoliation numbers build up, and then kind of trailing the years after that, seeing the oak mortality that kind of followed that. 2019, population crashed. We were back to very low level numbers. 2020, we really didn't see stuff, so we kind of were relieved. We thought we got past it. But this last year in 2021, we really saw a buildup, starting to build up again in western Massachusetts. So not seeing much out in central and eastern, but in Franklin County and Berkshire County, we were seeing defoliation for the first time in a very, very long time. Even before the Entomophagum omega kind of came in and changed the game for gypsy moth, outbreaks out in the western part of the state were less frequent, less severe, because the oak component of the forest is just a little bit less out there. There are more areas with maple dominant and other dominant species in the forest, so it wasn't as desirable for gypsy moths. So it is weird that we were seeing a buildup out there, and we're a little bit concerned going into this year. But hopefully we'll see some of these caterpillar mortality events. So there's Entomophaga, kills a huge amount of the caterpillars. They also will build up and have viruses within the population. And as we've all learned in the last couple of years about how viruses spread, you need to come in contact with each other to spread that virus around a population. So it's really only when we have really high densities that the virus really kicks in and is really active. Sometimes we also see a lot of caterpillar mortality when we have cooler or weirder spring conditions. So sometimes the caterpillars will start to hatch out of their egg masses, but then it's like wet or cold, or it's just not favorable for them, and they can't really get up into the canopy and start feeding, and they'll kind of just die as new hatchlings on the egg masses. So our current population is out in Franklin County, Berkshire County, and it's not as continuous. It's kind of pockets where we were seeing this defoliation, but within those pockets, it was rather severe, where we'd see almost total defoliation in some of these areas. And we utilize winter egg mass surveys to kind of help us predict what to expect in the upcoming spring. And because there are all these environmental conditions and funguses and viruses and things that kind of impact what will actually happen in the spring for defoliation, this is just a kind of a guide to help us see areas where there's a potential for that population. So areas where there are enough egg masses to support a defoliating population. So luckily, still not seeing much buildup out in central and eastern Mass. We did see little pockets here and there out on the Cape and around the Quabbin Reservoir, where there are some egg masses above the background level. Since gypsy moth is kind of always present in our forests, you'll see 1 or 2 egg masses here or there, even when you don't have these outbreaks. But when you kind of build up and see 10, 20, 100, that's when we kind of get concerned. So we did see some areas with huge numbers, and it really seems to be focused in those oak-dominated forests. Sometimes out in the Berkshires, to get to some of our sites, you really have to hike in. So over your 2-mile hike in, you'll see a couple pockets of trees where you are seeing a lot of egg masses. You'll see areas where you don't see any egg masses at all, and some where it's very severe. So it is expected we will see defoliation this year, but we do not expect it to be very widespread, and we do see it expected to be kind of more localized to those oak focused areas out in the western Mass. I just want to talk about white satin moth because this is another one of those moths that were in the early 20th century, got established here in Massachusetts. But it hasn't been, it's probably one that many people don't really think of, haven't really heard of. And it's because it has a different host range. So it really prefers like willow species and poplar species, which aren't as big of a component here. It's a little bit less of an aggressive feeder than gypsy moth. So it's been here in Massachusetts since the 1920s. It's well established throughout the entire state, where we've seen little periodic outbreak events. But it doesn't have this kind of huge blowups that we see with gypsy moth or what they're seeing up in Maine with browntail moth. It kind of flies under the radar, but we do see areas once in a while where it is very noticeable. It is a pretty significant defoliation, and it can be impactful to the habitat, that specific site and habitat, because it does impact these areas that are usually wetter areas that are supporting willows and poplars. So losing that canopy cover can really influence those wet water areas a little bit. So there are definitely other moths out there feeding on our trees in Massachusetts, and there are other invasive moths out there. They're just usually not quite as destructive, so we don't always think about them, or they get lumped in with the guys that are a little bit worse. But precipitation and temperature are really, as our climate changes, are going to influence how these moth populations function. So these populations that have become kind of naturalized, well established in our state over time, they fell into a sync with these things like Entomophagum omega that help keep the population control, or Compsolaria fly that help keep populations down, or native predators that are feeding on them. But as our precipitation change, as our temperature change, how these insects function in relationship to our forests and our other organisms out there can really shift. So we're not expected to see in the Northeast a significant change in our overall precipitation over the course of the year as our climate changes, but how we receive that precipitation will really change. So we're going to see more severe storm events. We're going to have longer dry periods. And having longer dry periods is not great for a fungus that needs nice moisture to get activated. And then having temperatures about when insects emerge and when leaf emerge can kind of change the synchronization between some of these insects or some of the predators or parasitoids with them. So we're going to jump into poll question 1. So what is the new common name for Lymantria dispar, formerly gypsy moth?
So the question is up. You'll have 10 seconds more to answer the question. Poll is closed. Results are 91% said Spongy Moth, 4% said Fuzzy Moth, 3% Hairy Moth, and 2% Hungry Caterpillar Moth.
Thanks, Jeffrey. Yep, so the answer is Spongy Moth. I still need to get used to saying it and start adding it in, but there is going to be a more formal common name change coming through in the upcoming months. All right, so jumping into some of the phase of the piercing, sucking invasive insects that kind of came in the second half of the 20th century. And actually, a lot of these species got introduced into the United States in the early 1900s on ornamentals, were planted in landscapes or in orchards, and then later moved into our forested areas and became bigger forest pests over time. And Parathrips is one of those. So, and the name applies pears. It is on pears and other orchard species, but it actually does feed very well on maples, particularly sugar maples. So in the late 70s, early 80s, it became an issue in New England on our sugar maples, and then kind of fell out, was a kind of a big issue, and then we really haven't seen it in quite a few decades. But I did get some reports last year that people were noting some Parathrips damage. And since it hasn't been a big issue, hasn't been very noticed, talked about, sorry everyone, in quite a while. People probably don't know what to look for with Parathrips, and they're very tiny, and they feed very early in the season. So you're seeing this damage by June, and then it kind of can get covered up later in the season. So you'll have this damage on the leaves, and it can get covered up by things like anthracnose later on in the season. So it's not always, when the population isn't very severe, it's not really devastating to the leaves. It doesn't always cause early leaf drop, but you have kind of like these gnarled little maple leaves on your sugar maples. So if you have sugar maples, keep your eye out, keep your eyes peeled, and I love to hear if people notice these kind of things out there. And then probably our biggest of these kind of feeding, piercing insects has been Hemlock Williadelgid. So Hemlock Williadelgid took some time to start getting established in the United States, moving from some of the states southern to us and coming up. And it got to Massachusetts in 1989 is when we first identified it. And it's very tiny and small, and can move really easily. It can get blown on the wind. It moves really easily on birds who are using hemlocks as habitat. So it can fly huge distances on birds. So once it got to Massachusetts, it very quickly spread throughout the state. So by the early 2000s, it was present in nearly all of our counties and most of our communities that had significant hemlock stands. So the population can kind of fluctuate, but when times where we are having high densities of Hemlock Williadelgid, it's pretty easy to identify. So if you flip over a hemlock branch and look on the underside, you'll see these fuzzy white balls right at the base of the needles. So the adelgid kind of get right where the needles meet the branch and kind of latch in there right at the base of the needles and cozy up. And in the nymph stage, they'll be kind of black. They're a little bit harder to see unless you have a microscope or a lens and are really looking in there. But as they mature to their adult phase, they start producing that waxy white coating, getting nice and woolly. And in that wool coating is when they'll produce their eggs. So even when those adults die, sometimes the wax coatings will stay, so you'll see that fuzzy whiteness even after that generation has passed. But as you kind of have this feeding pressure, they'll be under all those needles, they'll be doing a lot of feeding. It really just stresses the trees out, and over time the trees will lose some needles, they'll lose their vigor, and they become more susceptible to other insects and pathogens that are just naturally abundant in our forests. Things like Hemlock Borer will get in and start boring in it. Then woodpeckers will come in and start feeding on those. And then other woodpeckers will come in and start making bigger holes and make their homes in these trees. And then you can just have very rapid decline in stands of these trees that just are continually stressed out by Hemlock Williadelgid. In areas in southern United States, they see a much more rapid decline once you have Hemlock woolly adelgid in your stands. But here in Massachusetts and in our neighboring New England states, it can be a much slower decline. We've had areas that have had adelgid now for over 30 years, and they still have trees. They may not look the best all the time. They're not the most beautiful hemlocks, but they're surviving, they're out there. And a big thing is that our winter temperatures can really impact the adelgid populations. So when it's very cold, like very cold temperatures, it can kill a lot of them, but also those days when we have really sudden shifts in temperatures. So when it's 40 degrees, then 0 degrees, and 20 degrees, and -5 degrees, and that bumping and rapid fluctuation can significantly impact their population. So there are years such as 2018 where over 90% of the adelgids die during the winter. So it just knocks that population right down. But we have years like 2020 and 2021 where we only see about 40 to 45% of the population killed by winter temperatures. And when we have those mild winters, especially 2 of them back to back, the population can really build up. So right now we have very high densities of Hemlock woolly adelgid. There are also 2 generations per year. It's called a bivoltine generations. So there is a generation that hatches in early summer, usually around June. It kind of rests in a nymph stage over the summer, not very active, kind of just waiting it out, but it really thrives in those cool fall temperatures. So in September, it starts to get really active, it starts really feeding, and throughout the early winter, it starts to mature into that adult life phase, and it'll lay eggs usually around February. And then those will hatch, and you have a much shorter second spring generation. And it's an all-female population in Massachusetts, so you only need 1 adelgid left. So if 99% of your population dies, even if you just have 1 left in a stand, with these 2 populations a year, that they can really rebound pretty quickly. And even if every adelgid in your stand dies and your tree is looking great, since they do move so easily on the wind and with birds, it can easily become reinfested again. And having a couple years of mild temperatures can all of a sudden, your trees are looking fuzzy and white once again. So in Massachusetts, we try to do a few steps or have a few programs to try to control Hemlock woolly adelgid and help support our hemlock resources, since they are a significant forest type and particularly important around water resources and shading, and really like a unique habitat type here. So we have tried to establish biocontrol species. So the biocontrols for Hemlock woolly adelgid are actually predatory beetles. So they are little beetles that will feed on the adelgid. And we have not had great success getting them established here in Massachusetts. So we have released them since the late 90s. There's been 2 species we've released, Sasagus gymnosugi and Laricobius nigrinus, and we've released them throughout the state in multiple locations, and we go back every year, and it's called beat sheeting. So we go back when they start to get active in the fall, and we will go through the small trees and kind of knock the branches and look for the beetles. And we have very, very limited recovery. I personally have never recovered a Laricobius, and I've only seen 1 Sasagus gymnus. So we do have challenges getting these species to establish here in Massachusetts. Some of the southern states and mid-Atlantic states, they have actually had really great success getting them established. And part of the issue we have is the cold winter. So sometimes the predatory beetles themselves don't do well in the winter, but they also don't do well when their food source is suddenly disappearing. And it's been challenging for us to get biocontrols established. But a lab at Cornell is working on a new biocontrol species. It's a silver fly, they're a Leucopus species. And these are flies that feed on the population. And they're working with researchers at UMass to get those flies reared, selecting sites and getting permits done to hopefully this year release them in Massachusetts. And it seems like those will be probably better suited to our climate up here. They feed on that shorter spring generation, so they don't overwinter and in an active life phase as much as the other ones do. And we're really hopeful and excited to see what happens. Our hemlocks also suffer from elongate hemlock scale. So it is a small flat scale insect that's on the underside of the needles. So if you flip the needles over, you'll see them right on the needles. And if you look from the top of the needle, sometimes you'll see yellowing, discoloration, dull color that's caused by their feeding. So this is another one, came in on ornamental stock, and in the last couple decades has really moved through Massachusetts and established in our forested landscapes. Elongate hemlock scale can also get on Christmas, it impacts Christmas tree growers, particularly Douglas fir. So sometimes if you have a Christmas tree farm next to an area with hemlocks, those can it can move back and forth between those populations. And unlike the adelgid, it is not hit back by our winter temperatures, so it is a bit more persistent. So while the insect itself isn't quite as damaging as the adelgids can be, it is much more persistent year after year than the adelgid population is here in Massachusetts. And we do see the greatest decline in hemlocks that have both this hemlock woolly adelgid and elongate hemlock scale. But we are seeing some areas that are declining just from the elongate hemlock scale. So when we do choose to treat hemlocks, so we treat some high priority hemlocks in state forests, we use a dinotefron based product because it hits both the elongate hemlock scale and the hemlock woolly adelgid. For the adelgid, you can use imidacloprid products as well, but it is not quite as effective on the scale. All right, and moving on to poll question number 2.
Okay, the poll is up. Poll question will close in 10 seconds. Poll closed. The results are 86% said 2 generations, 7% said 1, 5% said 3, and 2% said 4.
Thanks. Yep, so 2 generations each year, which allows that population to kind of build back up again. So another of these scale insect is red pine scale. So red pine here in Massachusetts are not really native. We're a little bit south of its natural distribution range, and a lot of the red pine we have are plantation style trees. So stacked in really close, haven't really been managed because that kind of plantation growth fell out of favor since then. But these little insects really get in there and can do quite a bit of damage. So they're once again really small, feed right at the base of the needles, but they can get really dense. And these plantation pole size red pines, they're like little lollipops. They have such little foliage to begin with. So as it kind of gets impacted by these scale insects, they can decline really rapidly. And our land use over time has really really changed. So these areas that were just plantations, forested, just for timber and logging, harvesting, have now become areas that are parklands, campgrounds, homes built in here, and it does become dangerous to have these trees that are rapidly declining, and there's been a need for management of some of these red pines. So some landowners choose to do preventative cuts before they start declining in areas where these trees that have declined and are dead are near resources, homes, recreation areas. We do need to remove those dead trees. This is a picture from a state park where a preventative cut had been done in one area, but they didn't move into a second area, and you can kind of see all of these red pines that have kind of declined in the very short time since just that area was preventatively cut before the decline started. So once the insect is rapidly in there, it kind of goes really quickly, and mild winters really favor it. It just is able to feed really well throughout mild winters and just kind of accelerate that decline, which is why in the last year or so we've seen a significant throughout the entire state amount of red pines that are just really starting to brown up, lose needles, and then eventually die. So moving into the 21st century of our invasive insects, and it really was the time of the beetles, and these beetles that were really destructive to our hardwood forests. And one of them is emerald ash borer. So this is a wood boring insect, so it's really cute actually. It's nice and very vibrant green, and it does its damage in its larval phase where it feeds just under the bark in the tree's cambium layer. So it feeds in galleries under there, and as the population builds and the feeding galleries expand, it eventually girdles and kills an ash tree. So it feeds on all of our native ash species. So white ash and green ash are really common here. White ash is more in our upland areas and is pretty abundant out in Berkshire County, Western Massachusetts. And then green ash is in our like our long river corridors, but is also an urban tree that is planted a lot in some areas. And then we do have some smaller pockets of black ash in wetland areas. So it first was introduced into the United States in the early 90s, was detected out in Michigan in 2002. And from there out in Michigan, it moved really rapidly across the United States. It is found in 35 states at this point and several Canadian provinces. And here in Massachusetts, we have it in, I believe, 226 towns at this point. So it is well established in our state. We first found it out in Dalton in 2012, and then later up in Essex County in 2013 and 2014, down in Boston, and it's kind of just been filling out everywhere since then. And the reason we're not seeing it so much in Southeast Massachusetts is there's just not a lot of ash down there. We've been looking for it, but it's not a big tree resource down in those areas. They have different forest types and habitats that just don't support as much ash. But we used to use, I'm sure many of you remember the days in like around 2010, the purple panel traps, and you'd see purple traps hanging out of trees all over the state. We eventually moved to green funnel traps that we used. We also girdled trees and dropped them and peeled it. But as the population has really spread and become established in so many areas, we detect most of our new towns through just visual winter surveys. So we drive around this time of year and look for trees that have woodpecker damaging, dieback decline, and then peel and look for galleries in the insects. So most of the state at this point, EAB has become well established in our known infested areas, and we are seeing a significant amount of mortality in our trees at this point. So we are moving through that initial first wave where it gets here, becomes established, and now we're seeing decline and loss of trees. And we have several things we do to try to combat this, and much like Hemlock Borer we do release biocontrols. Luckily for us, these seem to be much more successful. They seem better suited for our climate here in Massachusetts, and they seem to be establishing well in our forests. So we've released 3 species. So these are parasitic wasp species. So Spathius gallini, Tritascus planipensii, and Ubius agrilli. Spathius and Tritascus are larval parasitoids. So what looks like a stinger on their back is actually an ovipositor, and they put their eggs directly through the bark and into the EAB larvae. And then Ubius is an egg parasitoid, so it puts its egg into an EAB larvae. And we've released these at quite a few sites across the state. We try to get them in all counties where we've had EAB fines. Last year we released at 5 sites. We're hoping to release at 4 sites this upcoming season. There are additionally researchers in Massachusetts that have released at additional research sites as well, to kind of monitor how these populations are establishing and spreading. So it is looking good. I will say that these biocontrols don't always save our existing trees. We are establishing them to grow and move and develop with the EAB population, and we will lose many of our ash, but as new generations of ash grow up and this next regrowth comes through, we will have these on our landscape as a resource to minimize the impact from emerald ash borer. And kind of we're in that phase now of what we're expecting our ash forest to look like as we move out of this initial impact. And we may have some ash that are lingering. So in the next couple years, as we finish this phase of EAB's infestation, we'll be out on the landscape scouting and looking at areas where trees did survive infestations from emerald ash borer, and seeing how those kind of recover from that. And southern pine beetle is kind of our beetle of the future. So it is native to the southern United States, and has kind of been a pest down there historically. And as temperatures warm, it kind of just keeps creeping up higher and higher. First, there was an issue down in New Jersey, and then in 2014, there was a big outbreak in New York on Long Island, and it's kind of just moving its way up the coastal areas. As the name implies, it likes pine trees, and it has a pretty wide host range, but it has definitely preferred species, and its preferred species here in Massachusetts are pitch pine. So at risk are areas that have our coastal pitch pines out on the Cape, the islands, Plymouth County, where our biggest pitch pine resources are. So it is a very small beetle. It is smaller than a grain of rice, and they feed under the bark in these galleries, and that's where the larvae develop. So they're very, very small, but they are able to overwhelm a tree by huge numbers. So the trees that get attacked release chemicals, and then the beetles that are attacking those trees release chemicals, and it draws other beetles in, so they aggregate into these huge densities, which are kind of able to overwhelm trees. And down in the south, they can have up to 8 generations a year, so the populations can really rapidly build and grow in these small areas. Up here in Massachusetts, we seem to have about 2 to 3 generations per year. And down in Long Island, when they were seeing outbreaks, it seemed like they were at 4 generations per year. So having a longer growing season allows them to have these more generations, build the populations more rapidly. And when you have these spot buildup and huge population outbreaks, it can move through a forested stand very quickly. So within 1 to 2 growing seasons, it can kind of spread out from a central point and cause a very rapid mortality. So you'll have a tree that looked healthy going into the growing season, and you can have a pocket by the fall where they're totally browned up, red, and pretty much dead trees. So we have trapped for southern pine beetle here in Massachusetts. We use these black funnel traps, and we've detected it in quite a few areas, but we find it in very low numbers. So we usually catch like 1 or 2 beetles in a trap, compared to like even down in Long Island, they'll catch like 1,000 beetles in a trap. So very low numbers. It is here, but it is not. We haven't found it in a tree here in Massachusetts yet. Recently, I'll go back to this actually to show the map. So recently, in New York, they found it at the highest latitude so far. So over here, they found it in Copake, New York, and in a tree, which was only about 700 feet from the Massachusetts border. So it's not limited to our areas that we think of with pitch pine in the coastal areas, but we can find it in some of these interior pitch pine stands as well. So this is the tree in New York that they found it in. And this is what our pitch pine resource in that area of Massachusetts looks like. So it's these really ridge tops, scrubbier, smaller pitch pines. So we will be trapping out in that area and doing more ground surveys going into the summer months, but we haven't seen anything in our trees yet out there. And as our temperatures warm, as our growing season length increases, as our winters are more mild, it increases our risk for there to be a southern pine beetle outbreak. So this projection of where Massachusetts kind of falls on temperatures going forward in the upcoming decades, it kind of pushes us down into those mid-Atlantic and southern states where southern pine beetle is an issue. And finally, I wanted to end with one. I feel like it's kind of, it can feel really negative talking about invasive insects, but Asian longhorn beetle is one that we can actually have, we can eradicate. So we have an eradication program, a cooperative program between the DCR and the USDA APHIS. And because of the size of this beetle, the host it's on, its life phases, we are actually able to detect trees it is in, remove those trees, and completely remove it from the population. So it was first found in 1996 in New York, but there's been several separate introduction events into the United States. So one here in Massachusetts, in the Worcester area, out in Chicago, in Ohio, and down in South Carolina. So we have found a lot of infested trees here in Massachusetts, and we removed those trees. We also preventively have removed other host trees around those trees, and we are making significant progress. So compared to early years of the program where we had thousands of infested trees in 2000 and then 2001, we have only found a single tree each year. So we are closing in on that population, and we are feeling fairly confident that we will be able to eradicate it. So we have ongoing survey efforts. So if you are out in the Worcester area, you might see us out around your house with binoculars. You might also see us hanging traps out of trees. Even if you are not in the Worcester area, sometimes other areas of Massachusetts, we will trap and survey just as preventative regulatory measures to make sure that our quarantine is effective. All right, and moving on to our final poll question.
The question is up. Poll question will close in 10 seconds. Poll question closed. As results are 71% said all of the above, 22% said southern pine beetle, 5% hemlock borer nilchid, 2% none of the above, and 1% Limontria dispar.
Thanks. Yep, so all of the above. So As our winters warm, as our summers warm, and we have increased growing season length, as our precipitations pattern changes, as our storm events change, it will alter how a lot of these insects function in our landscape. So what does the future hold for us for invasive insects? And unfortunately, it's probably not great. We will probably have new invaders. We have all these new introduction events. We have different pathways that insects are coming here. And we expect altered impact of these invasive species, but also altered impacts of some of our native forest pests that exist there. And additional stresses like drought, storm damage will compound our pest issues. So some of these pests that might not outright kill trees, but stress them out, when those stresses are combined with these other climate change stresses, it can cause to more rapid decline. But if you ever have any questions or things to report or things you want to show me or talk about, here's all my information. Check out our website. We have a really great story map linked on our mass.gov site where you can, it's an interactive map, so you can see our aerial survey and zoom into your area or look by pest, which is really a nice feature instead of us just sharing a PDF.
Excellent. Well, thank you so much, Nicole. Awesome presentation, a lot of great information, and we're getting that feedback from today's listeners. And we have a bunch of questions, so I'll just jump right in so we can get time to answer those before we do the final pesticide and association credit information. So again, just a reminder to our participants to please hang in there, especially if you want pesticide and association credit, don't log off yet. Okay, so Nicole, first question for clarification, what is an abiotic factor?
Oh, so abiotic factors are things that they're not our living things, so not our insects and our funguses and our bacteria, but things like weather events, so like winter injury, wind events, tornadoes, drought, so things that are not living that impact our trees.
Thank you. Another question from Bonnie. Nicole, would you be able to go back to your timeline in the beginning of Spongy Moth? Bonnie's asking, just could you re-show that with the pictures again for a bit longer?
Oh yeah. Also, if you go to our mass.gov website, so if you just go to mass.gov and search like Lymantria dispar, I do have it there as well if people want to look at it in the future, but I will get us back.
Great, thank you. And while you're doing that, I just wanted to respond to, we had a flurry of questions about why has the common name for Lymantria dispar recently been changed to Spongy Moth. And just if I may, the Entomological Society of America, which is the professional society that entomologists such as Nicole and myself belong to, they are currently undertaking what they're calling a Better Common Names project. And this is to eliminate the use of insect common names that have been used historically that have racist or other inappropriate connotations. So in this case, the word gypsy unfortunately refers to the Romani people of Europe, and it is a derogatory term. So it is currently being phased out. So we appreciate folks learning the new common name, Spongy Moth. Okay, great. Thank you for sharing that. Again, Nicole, here, another question. Let's see. Oh, this is from Edward, and he was curious about this for Browntail Moth during Tom's presentation as well, but I ran out of time to ask it. So he's asking about, I think, the same for Massachusetts, either for Browntail Moth or perhaps Spongy Moth. Curious if we could use AI to determine the damage from these insects. He suggests that this area of research appears to be an area where numerous PhD dissertations from different states could result. There are a number of satellite transmissions collecting filtered IR and visual data. Could the USDA provide grant funding? So some comments, questions in there, Nicole. I don't know if you can or would like to comment on that.
Yeah, so it actually is. It's something like I talk about with my collaborators in other states all the time. and using machine learning. So in 2020, we weren't able to fly for our aerial survey because we couldn't get into a small airplane altogether and breathe our germs around. So we were using disturbance detections from satellite. So there is a lot of satellite data being collected all the time, and a lot of it looks at like differences from your background, normal like color signatures, and looking for different patterns. So there is a move to do this machine learning to kind of like pull out what this is. And there are groups like researchers that are working on it. And I know that some are in the kind of the phases of it needs ground truthing, because we need to say like, yes, this was Gypsy Moth and that's what the signature means. There's a lot of different components to it, but it is really cool. But we do have some struggles here. It is really useful like out in like mountainous regions in Colorado where they are trying to find like beetle issues from like mountain pine beetle. It does become more complicated in areas like Massachusetts, where we do have really high human influence densities. So we have like houses and roads where like trees are all interspersed in that. And sometimes that can kind of throw off the signatures. And that was some of the troubles we were having using the satellite disturbance data instead of aerial survey data. But I'm sure it's something we can teach AI to get around. So I would say hopefully in the next decade, we do get more tools like that available to us.
Thanks so much, Nicole. Let's see another question here from Donald. Does the white satin moth feed on tulip poplar?
I don't think so, but I don't know for sure.
That is my gut reaction. That's Liriodendron, correct? Whereas poplar is populus, so a different genus.
Yes, yeah. I mean, I know it is a different genus. It could also feed on that, but I don't think it does. But we don't have a ton of tulip poplar, and we don't have a ton of satin moth outbreaks, so I don't know how their overlap is.
Thank you. Let's see here from Sean, and I think others had this question again, if you may clarify about browntail moth in Massachusetts. Sean's asking, are there any current sightings on Cape Cod? Can you just go over that again?
Yeah, so there's always, I mean, it's always part of our forest, so there are always like low-level populations. Particularly the area that's like out like towards the end in the national seashore properties. We do see you can find webs pretty much any year, but they're usually not very numerous, not very dense, not very widespread. It's usually like little pockets here and there. And then areas on the North Shore like Plum Island, there's usually a couple there too, but it's very scattered.
Thank you. Another question here from Kathy. Do you know if native birds will feed their young spongy moth caterpillars, or do native birds eat spongy moth caterpillars?
There are some birds that will feed on them. They are hairy, kind of gross, so they're not like a very preferred food source. And there's also just like a huge, when we have these outbreaks, there's just so many of them that even the birds feeding don't make a big impact. The thing that actually feeds on spongy moth the most are mice. Feed on the egg masses in the winter and fall, and that has like the most significant impact to the population.
Thank you. Let's see here, another question from Phil. Hemlock woolly adelgid, what is the maximum cold temperature that affects the life cycle, or is it just anything below freezing?
So freezing, if it was just like 30 degrees, it'd be fine. It's usually when you get to that like 0 threshold that kind of influences them. But it's not always a hard number. It's kind of how you get to that number. So if it's 0, but like it's very gradually building down to 0, they can kind of like harden themselves and like prepare for it, versus I feel like one day it's been 40, it's been 30, and then all of a sudden it's 0. That's more shocking, and we see more mortality with that. But usually it's around that like 0, negative low single digits that we really see mortality.
Thank you. I'm going to jump around a bit. This related to you talking about your aerial survey. How do you distinguish between the different types of infestation or who is defoliating what? This is from Juliana.
So sometimes, like from the air, the signatures of how things show up are a little bit different, so we have a good idea. But we actually go out on the ground and we look for different signs. So different feeding patterns, like so how different caterpillars feed on leaves are different. So sometimes like you'll see remnants of leaves and you'll be like, oh well, obviously like this was Gypsy Moth, or Gypsy Moth usually eat everything and they're gross. But sometimes there'll be the next generation, or the egg masses or pupae or signs will still be there. So with Gypsy Moth, there's usually like pupal casings left on the trees, and you can find egg masses. Things like forest tent caterpillars, you can find egg masses on branch tips. So looking for the different signs that they leave behind, or trying to see if they're still hiding there.
Thank you. Another question from Paul that relates about Hemlock woolly adelgid mortality over the winter. He mentions that he has a branch of a hemlock tree on his property that he picked this morning. There are many white spots on the branches, not very large even with a magnifying glass, and he can't tell if they are alive or dead. And he notes that last summer our hemlock trees were loaded with adelgid, which has killed trees. Many trees do not have very many needles on them. So he's wondering, I guess, how can he tell if the adelgids are alive or dead over the winter, and what type of magnification is needed to be able to do that?
So when we do our mortality counts, we do use dissecting microscopes, and I think we usually like 40 times magnifying, or maybe 10 times. But you definitely do need a microscope to be able to tell, because when they die, they're still have made wool and they're still like already get to that adult phase. But what we have to do is like, so we pull the wool back and then you have to pop them with like a little sharp thing, and see like not just if they pop, but like how they pop, how their like internal juices run. Like it is kind of a complicated process. It's not very easy. And most of the time you won't really notice the mortality until next winter. You'll be like, ah, there's less of them. They must have died back last winter. So it is challenging, and you do need a microscope to be able to really tell if they're alive or dead.
Thank you. A question from Sue, asking about the predatory beetles released for Hemlock woolly adelgid. Are they native to the United States, and if not, where are they from?
So the Laricobius nigrinus are native to the western United States. So in the western United States, they have western hemlock, and on the western hemlock, they have a Hemlock woolly adelgid species as well. But that is, they believe, has kind of been there for thousands of years and developed with these trees, and it feeds on those. So they actually go out to Washington and British Columbia and capture them and send them back to us here to release in our forests. And then the Cytisus gymnus is from the native range in Asia, and then was lab reared here in the United States and then released.
Thank you. Let's see, question from Sue. Do you find the elongate hemlock scale and Hemlock woolly adelgid co-occurring on the same trees?
Yes, elongate hemlock scale has become really well established throughout nearly all of the state at this point. So here in Massachusetts, I see them together more often than not, unfortunately.
Thank you. Let's see, from John. Oh, is the elongate hemlock scale also affecting the spruces and Scotch pine in our area? He mentions he's from Franklin County.
I don't think it is. I think that a lot of what we're seeing in our spruces is kind of climate change related. So for some of these spruce species, So some of the native ones, we're on that southern edge. We have these really smaller areas that were suitable for them. And as our temperatures are warming and we're going through more of these droughts, those areas that are suitable are kind of shrinking. And so we're seeing a lot of just like decline and fungal pathogens in the needles and roots, as these areas just become a little bit less suitable to those native spruces. And then for some of the planted spruces, things like our Norway spruce or things like our Scots pine that are not native but had been doing well here. Some of it's also just like fungal from we had some wet falls, but then dry summers that kind of negatively influenced them.
Thank you. Let's see, from Bonnie, was the biological control for Hemlock Willia delgid released in the Framingham area? She's specifically asking about garden in the woods.
I am not sure. So some of that happened before my time, and since we haven't always had great recovery, some sites I just have like a point on a map. I don't really know too much detail about it.
A question here from Scott. Once emerald ash borer establishes in an area, what is the mortality rate of trees? Is there any chance an ash tree with minimal damage can be saved?
So the range of mortality can actually really wildly vary. About 2 years ago, a paper came out from years of research they'd been doing in the Midwest, where they've had emerald ash borer for a bit longer, and going through like white ash stands. Some of them they would see almost half the trees surviving. So there is a chance that trees might not die. It is challenging with ash because they do become brittle and very dangerous. So when they're around homes or streets or cars or parks, it's not always safe to keep them, even though they start declining. But in forested areas, if you're not managing for it, it's fine just to leave trees and kind of see what happens. For trees around your home that already are infested, it's usually not worth it to try to treat them at that point if you're doing pesticide treatments. The pesticide treatments are usually systemic, so you inject them in and the tree will take it up and move it around. And kind of once you have some EAB making galleries in that cambium layer, it can kind of it can restrict how that chemical is moving and make it not as effectively spread around. So it's kind of a waste of your time and money to start treating if you do know your tree is already well infested. If you are in an infested area and your tree is still looking good and doesn't have any dieback, you can still treat and it can protect it. But once you kind of start seeing those telltale signs that you have EAB, it's usually too late to treat.
In your experience, Nicole, I've heard others state that you could potentially treat an ash tree until you see greater than 30% dieback in the canopy. Is that your experience, or do you feel that should be a little less?
So it depends on your tree. I've really stepped back from treating urban ash because they get damaged from things like weed whackers and mowers and plows. So they kind of already have this damage that's like on their base that's restricting movement, and then any amount of EAB damage is also going to limit the effectiveness of the chemical to fully get through the tree. And then we just have to come through and prune or take it down anyway. So if you have a tree that is otherwise pristine, has no other damage to it, not a lot of other site stress, I'd say, yeah, that 30%, if you're using emamectin benzoate, you could go for it. But if it is like a kind of beat up or stressed urban ash, I would not suggest if there's any EAB damage treating.
Thank you. Let's see here. Another question. Does emerald ash borer have other hosts besides ash or fraxinus?
Tony, you might know. There's like one other tree that it can survive in, but it's very uncommon, and I am blanking on what it is.
It's
Ionanthus virginicus. Oh yeah, was that what you
yeah,
were going to say, Tom?
yeah, white fringe tree. And I think there is a question. So since both of those groups are in the olive family, I think there's a question as to when it gets to California if it can also infect olive trees. So stay tuned, I guess.
Yes, I thought I saw a paper a while back, European olive. I might have that wrong, but I agree with that olive connection as well. So thank you, Tom. Thanks, Nicole. Let's see here. Oh, a question from Chuck. Are there any ash seed collection programs ongoing to help reestablish the ash once EAB begins to wane and hopefully biocontrol kicks in or continues to kick in?
There have been. So there are a number of researchers that have kind of been looking into kind of collecting ash for resistance, but also kind of collecting seed resources as well. And here in Massachusetts, we specifically don't, because we just don't have that sort of resource. We don't have like nurseries or research nurseries or things like that. But there are other locations, and they do collect from throughout the range of ash in the United States to kind of get a good sample set.
Thank you so much, Nicole. And